Hey guys, welcome back. We are doing problem number 7 today, which is another hypothesis test. This one's going to be about a student that was making a claim about the length of time that it takes to do her homework. So let's read this one carefully. We'll make sure we write down all of the important information that they give us inside of the problem, and we'll start making decisions about what kind of a test we are going to do. All right, so it says a student of mine claimed that the homework in her statistics class is too long. I told her that the average time a student took to complete the homework was 20 minutes. She claimed it had to be longer since it took her forever to complete it. Using MyOpenMath, I was able to monitor how long each student spent on their homework assignment. Using a randomly selected sample of 37 students, I found the average completion time was 27 minutes with a sample standard deviation of 4.2 minutes. We want to test the student's claim at a significance level of 0.05. All right, so let's go through here. So I told her the average time to complete the homework was 20 minutes. So this would be the assumed average amount of time. So this would be what we would refer to as mu with a little naught, or the assumed population mean. So we're going to say that is 20. The next thing she said, she claimed it was going to be longer since it took her forever. That's going to help us with our null and alternate hypothesis. Okay, so we'll write that down in just a little bit. So using MyOpenMath, I was able to monitor how long each student spent on their homework assignment. And I took a sample of 37 students, so we know the sample size is 37. The average completion time was 27 minutes for that sample, so our sample mean was 27, right? So we were expecting 20, we got 27, and it had a standard deviation of 4.2 minutes, and that's a sample standard deviation. I'm going to put 4.2 for that. And we want to test the claim at a significance level of 0.05. So alpha will be 0.05. That should be all of the important information that we got from that problem. All right, so the student's claim, right? So remember, her claim was actually up here in this sentence. She claimed it had to be longer than 20 minutes since it took her forever. So her claim is that the mean amount of time to complete the homework is greater than 20. So when I write my null and my alternate hypothesis, okay, here we go, I'm going to set this up. The assumption usually goes in the null hypothesis, and we try and put the claim in the alternate hypothesis. So the assumption was that the mean is equal to 20 minutes, and the contradiction to that, or the claim here, is going to be that the mean is greater than 20 minutes. So this is our setup for the test. All right. So does that make this left-tailed, right-tailed, or two-tailed? Since we're going greater than in the alternate hypothesis, this is going to be right-tailed. Okay. All right, so the next step here is to find the value of the test statistics. Remember, the test statistic tells us how many standard deviations away from what we expected, right? How many standard deviations are we away from 20 minutes? And we also have to make a decision about what type of test we're doing. Are we doing a t-test, a z-test, or a one-prop z-test? And for this one, we're going to be doing a t-test since we don't know the population standard deviation. Don't know this piece of information right here. We have a sample standard deviation, but we don't know what the population standard deviation is. Okay, so our calculation for our test statistic, we would say t instead of z. Remember, we did z in the last problem. This time it's going to be t for our test statistic, is going to be our sample mean minus our population mean, which is our assumed value, divided by, and we're going to take our sample standard deviation, right? Because we don't know our population standard deviation, so we're making a substitution with the sample standard deviation divided by the square root of n. Okay, so this is our calculation for the test statistic. So I'm going to start plugging in all the things that I know. So from the stuff that we wrote down up here, we know that the sample standard deviation was 27. So we've got 27 minus our assumed time, which is 20 minutes. And then our sample standard deviation was 4.2 divided by the square root of our sample size, which was 37. All right, so I've got everything plugged in. All I got to do is crunch the numbers in my calculator. And if you do it correctly, you should get 10.14. and it should be a positive 10.14, indicating that we went 10.14 standard deviations to the right of what we expected to get, which was 20 minutes. That's a lot of standard deviations away, right? So remember, anything more than 2 or less than 2 standard deviations away from that expected value is considered rare. So getting 10 standard deviations away is very, very rare. All right. So we want to calculate the probability of getting this. All right. So that's what our p-value does. And we're going to use a t-distribution to do this. And remember, a t-distribution looks a lot like a normal distribution, but it changes the shape of the curve based on the sample size that you take. All right. So it's going to look like a normal curve when you draw the picture of this thing. And somewhere over here on the right-hand side of our distribution is our 10.14, right? 10.14 standard deviations to the right of what we expected to get, which should be the center of our distribution. In this case, it'll be 0 since it's standardized, right? And we want the area in this tail off to the right. That's what we're trying to find. But we can't use a normal CDF to do it. Instead, we have to use TCDF since we're working with a student's t-distribution. So we're going to say TCDF. We're going to tell it our lower bound, which is 10.14, and then our upper bound, which is 1E99, and it wants to know our degrees of freedom. So remember, degrees of freedom is always one less than the sample size. So that's going to be 36. So this is what we'll do in our calculator. I'm going to pull up my calculator and let's see what we get. I'm going to go second vars and we'll go down to option 6 right here where it says TCDF, and we'll enter in all of our stuff. Oop, I accidentally did inverse norm. So we want to go to option 6, TCDF. Weird. Oh, I know what I'm doing. All right, I gotta get out of that. My bad, guys. So there we go. So we want 10.14. And then our upper is 1E99. And then our degrees of freedom was 36. That's all it needs to know. And there we go. We got 2.13 E negative 12, which is essentially 0 plus. All right, so that is the probability of getting 10.14 standard deviations away from what we expected, assuming that the actual population mean was 20. So that would be extremely rare. It'd be nearly impossible for that to happen. So we get to make a decision based upon that probability. All right, so again, this thing about finding the critical values, you do not need to do that part, so don't worry about it. But helping us here with our conclusion, we use our p-value, which is 0 plus, and we compare that to our significance level, which is 0.05, and 0 plus is certainly less than 0.05. So this is telling us to reject the null hypothesis. It is so rare to get this number or to get this test statistic that we should no longer believe that the null hypothesis is true. All right. So what I'm going to do is I'm going to write this in the context of the problem, because we don't just want to say reject the null hypothesis to people that don't know anything about stats. All right. So we want to make sure that we write this in a way that people can understand what conclusion we came to. All right. There is sufficient evidence to support the claim that the homework takes longer than 20 minutes to complete, right? And that's what the student was claiming in the first place. So the student was right. The homework does take longer than 20 minutes. There's enough evidence to support that claim there. So I might, as a teacher, need to go back and take a look at that homework. If I was expecting it to take 20 minutes, well, it's clearly taking people longer based on the evidence that was provided. So I need to go back and make adjustments on that homework, or at least adjust my expectations and say, you know, maybe my expectation is that homework should take 30 minutes or something to that effect. All right. So then we would look at the different types of errors as well, make sure that we can describe a type 1 and a type 2 error. You might need to do this on the test. So there was a nice little diagram that you're more than welcome to use while you're taking the test to help you out with deciphering what a type 1 or a type 2 error is. All right, so in this case, a type 1 error is going to be rejecting that the mean is 20 minutes, right? So we're going to the mean. Okay, so we're going to reject that the mean is 20 minutes when it is actually 20 minutes, right? So it's like rejecting the null hypothesis when the null hypothesis is true. That's the definition of a type 1 error. So in the context of this problem, what that means is we're rejecting that the mean is 20 minutes when it actually is 20 minutes. That would be a type 1 error in the context of this problem, right? So for a type 2 error, a type 2 error is failing to reject the mean as 20 minutes when it is actually more than 20 minutes. So we fail to reject the null hypothesis, right, when it is actually false. Okay, so that's the technical definition, but in the context of the problem, that would mean that we are failing to reject that the mean time spent on homework is 20 minutes when it actually is more than 20 minutes. Okay, so that concludes describing type 1 and type 2 errors. Again, on the test, I would recommend having that chart with you so that you can use that to decipher what a type 1 and type 2 error is and its technicality based on that null hypothesis, and then make sure that you reword it in the context of the problem correctly on the test. Okay, so to wrap up here, what we're going to do is we're just going to run this thing on the calculator real quick so that we can compare the results that we got from doing it by hand to what we got on the calculator. Remember, you're always free to use your calculator on the test, but I may ask you to do certain parts by hand. There are certain things that your calculator might not calculate for you. So make sure you know how to do the individual parts by hand as well, and you can use your calculator to verify. All right, so here we go. For this one, we did a t-test. So we're going to go to stat. We're going to go over to tests, and we're going to choose option 2, which is the t-test. And it's going to ask you if you want to do data or stats. We did not have the raw data, so we're going to choose stats. And it's going to ask you essentially what your null hypothesis is, right? What did you assume about the mean? We assumed it was 20. And the sample mean from our data showed that it was 27. And our standard deviation was 4.2. Again, that's a sample standard deviation. Our sample size was 37. And we were running a right tail test, right, which is already selected for us, so that's nice. All I have to do now is hit calculate, and there we go. So we can kind of compare what we got here. There's our 10.13. So remember, we got 10.14 with a little bit of rounding. So we can compare those, and we got almost the exact same thing. And then there's our p-value, which again, if you compare, we got our 2.13 e to the negative 12. The calculator got 2.15 e to the negative 12. Again, there's slight discrepancy in rounding, which is not too bad there, right? So same results from the calculator, and that's how you run it. That's how you run that t-test there, so you can check yourself at the end of those hypothesis tests. All right, guys, that's it for today. Have a great day. Tune back in if you need help on other problems.